Hello everyone, welcome to the Mammothon Tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Program Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the program, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
Okay, so welcome guys. So today I will present to you Dojo. Dojo, and I'm Glim, working at Cartridge, software engineer in Dojo itself. So what is Dojo actually? Dojo is an open source and community-driven toolchain for provable games and applications. And Dojo is currently built on the top of StarkNet, which is a L2 of Ethereum. And in the context of that, today I will present to you the toolchain. I will make you a quick demo, just getting directly into the code, just to show you how to work with Dojo. And in this short presentation, I will show you also where Celestia come into play with the Dojo stack and what we have for you for the hackathon. So the toolchain is composed of different tools. So at the left here, you have the different tools of the open source stack. Where you have a sequencer, Katana, you have Sozo, which is like a compiler using a Kero compiler to streamline your contracts developments. You have Torii, which is an indexer aware of all the things around Dojo. Origami, a library to write some games, and Saya, which is about proving as a rollup, Katana executing as a sequencer. And at the right, you have the cartridge specific stuff, which is services, which mainly are slot and controller. Slot is a managed infrastructure. So when you develop locally, you will use, for instance, Katana on your computer. But then when you want to make playtesting or when you want to share your games or application, you can just use Slot to, in a minute, spin up a Katana, a Torii, and then share those to others. I will show you also how it works during this demonstration. And then we have Controller, which is an embedded wallet, which allows you to use sessions to actually avoid users to be prompted each transactions they have to say that they have to sign to play or to interact with your application. I cannot see the question at the same time, Rebecca, so I will just go through, but if there is some question or something, just feel free to interrupt me at the same time. What is the Dojo architecture? So Dojo built on StarkNet. We are using StarkNet smart contracts to develop, and there is three there are three important entities in a Dojo architecture. We have the world contract, which is the central contract where all the data will be stored. And I will show you in a minute some examples. And then we have some contracts that we can use to interact with the worlds. And we have the models, which are actually the data that are stored into the world. So the models define the data, the contracts define the logic of the game or the application, and the world is the one actually centralizing those data. And we will see why in a minute. So how actually a player or a user will interact with the Dojo infrastructure architecture we just seen. A player will send transactions to a contract. The contracts apply the logic that you have deployed, and then the contracts will read and write from and to the world using the models. So you define the data with the models, and then you just read and write them from or to the world using the contracts. And how do you define models? It's very simple, and we will see an example in the code. You just define simple data using the type that Chiaro supports. And then you define some keys, and you can see that like almost a relational database at some point. You define some keys, which will define in the storage where the data will be stored. And then you can easily use those keys to actually get the data from the world or write the data to the world. So in this example, we have two models. The two models share a same key, which is player with the same type. But at the same time, the model B has an extra key with the game ID. And then we have the data on each of the model. So how this will be stored into the world? Well, simply having the key which identifies where the data will be stored into the world storage. And then you have the data actually being serialized and stored into the world. In this example, we can see that one of the model has two keys. So every time you want to interact with data, you have to know those keys, and then you can instruct where you want to store data or where you want to read data. So this is a very brief introduction, but this gives you an idea of how Dojo is architectured. So I don't know what to expect about the difference, like how people are familiar with Chiaro and StarkNet, but the idea is Dojo is built on the top of that, and should, if you know how to write Chiaro, and I will send all the documentation about this, then you will be able to easily jump into Dojo and use this, right? So how Dojo allows you to actually streamline your development of your application and everything is using the different tools we have seen in the toolchain at the beginning. So we have Katana, which is a sequencer. So if you work locally, Katana, it's where you will deploy everything just to test your contracts and work with them. And then you can also use Katana, as we have seen, to be deployed on a managed infrastructure, or you can directly deploy something, for instance, on StarkNet, testnet, or mainnet. So the idea is you have a sequencer, and then Torii indexer is directly pulling the information from Katana, and everything you change something into the world, it will be automatically indexed by Torii. So it's an indexer that is using on-chain introspection, so you don't have to define any files to get your types, etc. Everything is generated on the go, and then on the chain, actually stored on the chain, and then Torii will just get that and index this everything for you and put this into a database. And then on the client side, we will query that. Here you have the proving part of the stack, and we will get back to this in a minute. But the idea is when you are using StarkNet, the prover is actually sending the proof to Ethereum. In the case of Dojo, you can also choose to have a prover taking the blocks from Katana and then settling this into StarkNet, posting data availability into Celestia, right? So how Torii is actually giving you the data. So on the client side, you have a Torii client that can connect through GraphQL, gRPC. There is also now a raw SQL access if you want to just make reads with SQL data. And the Torii client will just help you getting all this data organized, and then you can consume this into USDK. Currently into Dojo, there is a Dojo.js SDK, there is a Unity SDK, Unreal SDK is almost there, and there is a bunch of them, so you can check them, and I will send the links also. Bevy is under development, is not yet stable, but the idea is whatever your platform is for your game or your application, you should have a Torii client available in WASM or in C directly, where you can generate bindings based on the framework or client your SDK you are using. So what I was mentioning about the flow with Celestia, this is what you can do with Dojo and what you will be able to do with Dojo. So you have a transactions coming into Katana. Katana produces blocks. Then you use Saya, which is a tool that takes the blocks from Katana and prove them. And then the proof is being sent on Celestia. And here we have two models. The first models is you can use a regular rollups on the top of StarkNet, or you can use what we call sovereign rollups on the top of Celestia. The sovereign rollups currently works into Saya, and in the coming days, we will have some announcements and some releases about this and tutorials. But the idea is you can post data to Celestia with Saya already. The only part that we are still working on is Katana being able to sync back from everything that has been posted on Celestia. So to have a proper sovereign rollups, posting things to Celestia is the way you get your data, and then Katana should be able to sync from it. And like this, you can just fork the chain wherever you want and then restart it with your node very seamlessly. So this is how the Dojo tool stack is connected to Celestia, and during this hackathon, we have proposed some idea of games. There is also some openings if you guys want to just try about more technicalities, like using some verifiers that we have on StarkNet and maybe try to make something in the browser where you can take some proofs from a chain that is being posting blobs into Celestia. And then you might take some information from there and make some things in the browser just to showcase how the technology can works. But this is how the things are connected. I don't know if there is questions for now, Rebecca. I want to jump into, because we have 30 minutes. So I think it could be interesting for users to just see how it works and jump into it. So I don't know if there is questions first, or if you have access to some questions I don't see. So I see some questions about latency in multiplayer. So currently the proving time is a bit long. So in the current pipeline we have, it's something that if we have only one proof to generate is around like 30-40 minutes. So it's something that is considered very long. However, there is a bunch of research and optimization in the StarkNet ecosystem with the two provers coming in, where the time should be drastically reduced. So currently, when we will provide all the documentation to use Saya, you should expect a proving time a bit long, which is shorter than StarkNet, which is around like 8-10 hours, but it's still long for your application. So yeah, this is something to consider. Okay, so let me just show you guys how it works from scratch, and like this, it gives you an idea how quick you can actually start hacking on Dojo and making things with it. So the first link that is interesting for you guys, it's the book of Dojo, where you have all the information about documentation, installation, and stuff. So let's just run this one and source it. And then using Dojo Up, I will just make it a bit bigger, perhaps it will be better. And using Dojo Up, you will just use it to install the latest version of Dojo. So as we have seen, we have the toolchain with the different tools. So here you can see Katana, you can see Sozo, and you can see Torii, which are the three main programs we will use today. And the last one is Saya. Saya will come apart from now, but everything will be linked for you guys to just use it and post blobs to Celestia. So how do we start when we actually just want to try something? Let's just use Sozo init, and we will use a Mammoth repository. Sozo init is cloning a repository that we call Dojo Starter, and Dojo Starter is like a simple example of what you can do with Dojo. So let's open this into a like text editor. So how it works? To work with Dojo, you have to know Chiaro. So Chiaro, there is a good book for you to learn how it works and the language itself. Chiaro is very similar to Rust, I mean, in the syntax at least. So this is something you can have easily jumping if you know Rust already. And the idea is, as we have seen during the presentation, we define data using models. So as you can see here, guys, we have a simple structure. We have the key. Do you remember we have a key to just identify the storage location and indexing at some point our fields. And then we have the data, right? And all the logic is then coded into a contract, what we call the Dojo contract in this case here. In these contracts, you will do simple logic where you can make some computation and using the data from the world. So as we mentioned, when you are using the models, you can write a model into the world or you can read a model from the world. So the world is where the data is located, and then the contract itself is usually stateless, and you will use these read and writes to actually interact with the models. So here we have a very simple thing. So when we spawn, for instance, we just get the position, the default position of the user, then we add 10 in the 2 coordinates, for instance, then we write this, and we can also write different models at the time, etc. So this is an example of a very simple contract. I will send you all the links for you guys to just like jump into the code, etc. So how can we actually easily deploy that and work with that? So the first thing I will do is I will actually start a Katana. So remember, Katana is a sequencer. So I will just start a Katana exactly as you will start an Anvil, for instance, working on Ethereum. And once I have the Katana up, then I can work and try to deploy it. So Sozo, which is, as I mentioned, that the compiler and streamlining tool to streamline your contract development. First thing first, let's build our contract. Those warnings will be gone in the next version. And once we have built our contract, we can see with Sozo inspect what actually have I built. So in this example, it's a bit big. Let's remove this. So we can see that we have the world contract. Remember, the world contract is the central contract for your application or your game. And then we have one contract, which is the actions contract we have open here. And then we have the models that define the data. The namespaces is something you can use in a more advanced scenario. So for now, we'll just ignore it. And there is one default namespace every time. And this is everything that will be created if I migrate all my project into on-chain. Okay, so here I am off-chain, coding, making build, and I can also test with Sozo. So Sozo build, Sozo test. And then I want to send this on-chain. So first, let's just send this into a local Katana, which is the one we have working here, right? So the command is simple on its own. It's Sozo migrate. So when I hit Sozo migrate, Sozo will actually check the state of your local contracts and the state of the remote contracts, which are supposed to be on chain. So if you don't have anything, Sozo will just migrate, declare and deploy all the contracts. And if you have just modified something in one contract, Sozo will detect the diff and will only deploy and update the contracts that have to be updated. Okay, so this is very like interesting way to just like very easily work with the contracts and know what's on chain, what's not on chain yet. So if I run an inspect again, then Sozo will compare what's on chain and what's locally. And then I should have the different status change. So now all my local resources are actually synced into the chain that I am targeting. And how I know the chain I am targeting is because there is a configuration file where you can define where this has to be migrated, what is the demo account in this case that I can use to actually send the transactions. And this allows me to actually just enter simple commands and work with it. So now if I go into Katana here, I can see some transactions coming in. And if I go back into my terminal, then I know my world has been deployed at this address. Okay, so I have the world here and I have my contract actions, for instance, which is here. The cool thing about Sozo is aware of all the names of your contract. So you never have to actually work with addresses. You can directly work with contracts names. So let's start now the indexer. So we have the sequencer running and we want to index those data. So if you remember, the tool was named Torii, and the only thing Torii has to know is actually what is the world that I need to index, because as all the data is centralized into the world, every time something is written into the storage, then Torii just have to monitor the world contract. The contract that you write, like the actions contracts, are just like at some point entry points for logic and not that much for state, right? All the states into the world contract. So then I will start Torii. And when I start Torii, I can see Torii already registering some things here. So he has seen some models that we have defined. So here we have moved, events, position, direction available, and moves. So if I get back into my models definition, I have my moves model here, I have my position model here, and this is how Torii will just grab it. And as you have seen here, I didn't have to configure anything on the Torii side, right? I just gave the world address and everything is on chain. So Torii has the capability of deserializing the types and exposing them. So now how you will consume those data. So to consume those data, Torii by default, which is on the 1180. So if we go here, we have Torii, which is launched, and then we have different interfaces. We have a raw SQL interface, which allows us to just check all the tables and you can just go raw into the database. This entry point is read-only, so you don't have any worry about modifying data. Then there is a GraphQL endpoint that is being exposed. So you have here all the documentation auto-generated by GraphQL with all the things that you can do to interact with Torii. And the last one you can have is gRPC. So in the gRPC interface, same thing. You will have different things that you can do, fetching entities or subscribing, which allows your client application to be more reactive. So you can subscribe and say, hey, every time those models have changed, I want to be notified. And then your client application can just take action. So here, for instance, let's take an example. I just try to fetch all the entities. So the entities are just all the data that are into the models based on the keys. And in this case, I don't have any entities. So how can I send a transaction very easily? To send a transaction, once again, as we mentioned, we have Sozo, and Sozo can execute a transaction. And as I mentioned before, you don't have to remember the addresses of the contract. Sozo knows everything from the code that has been compiled and generated. And then I can just go into my actions contract, which is the name is here. And then I will just try to call the spawn function entry point. So if I go here and I just go Sozo execute action spawn, then I have my transaction being executed. So if I go into Katana, I will see the transaction coming through here. And if I go to Torii, then I will see Torii making processing some events, right? So if I go back to my client application, in this case, it's just like a Kriya application, but it can be your front end or anything. Then I will just query again, and now I have all the data. And as I mentioned, Torii already knows about the types. So everything is being strongly typed arriving to your client application. And here I can see I have a model position. And then this is like the detailed view, but if you use Dojo.js, for instance, there is some abstraction and you will just have a simple object coming out. And then I can see I have my vector with the position 10 for X and Y, right? And now if I just try to move, so I will move up, or I don't remember exactly which one is, but I just give like the index of this in this case. So if I go into model actions, if I move, I can give a direction. And the direction is just an enumeration here. So 0, 1, 2, 3. So if I move 1, it will be right. So if I move right, then I query again, then I will have my data updated, okay? And here I use a query, but if you use subscriptions, every time something is changed in the world state, your client application will automatically be notified. So this is as simple as that. You develop a contract, you use Sozo to build, test, migrate, and then you can use like the Torii client to interact with your data. So this was a quick example, but here we have seen already different part of the stack and how to work with Dojo from scratch. And the last thing I want to show you guys before getting back to questions and wrapping up is when you are working during a hackathon, you usually hack locally and test it, but then you might want to just host everything for the judging or sharing or just working around. So as you remember, I told you about Slots, which is something that has been developed by Cartridge for managed infrastructure. So with Slots, you can have a list of deployments And those deployments, you can use different services. And the two services widely used currently are Katana to spin up a sequencer and Torii to host the exact thing that I have done locally, but remotely. So let's just create it. So I will just create here a slot instance with Mammoth one, let's say Mammoth, and then I will create a Katana, right? And I will just start Katana in the dev mode just to have more accounts being able to deploy stuff more quickly. Once I've done that, I'm just waiting this to be created. Slot is for now totally free, so you can download the client. I will send the links, and then you can work with it. You have like 3 deployments load. So here the deployment is available. The URL is this one. So now what I can do is if I go into my Dojo, I can have different profiles. So here I was in Dojo dev. So let's just go into the Dojo release one. So if I go into the release, I will just use the URL I have just deployed right now. The account, I think those accounts should be available. I will check that, but it should be on Katana. And here we have the account, which is here. So now using Sozo, I can just do that. Sozo build release. So this will build the code, but in the release mode, which match this profile. And then I can just do migrate. And now the migration is targeting my remote Katana, which is hosted on the slot infrastructure, right? So as you have seen, it's very small changes. You don't have a lot of things to do, and it allows you to just experiment and very quickly spin up something that you can have running and for testing or sharing directly. And now everything that I've done locally is actually done on the remote Katana. And what if I want to share this and I want to index this world, but not locally? I want also to index this world remotely. So in this case, I can do exactly the same thing. I can create something into the same namespace, same service name. And now I will just create Torii. And then I will give to Torii the address of the world, which is maybe create Torii. Oh yeah, I need a RPC URL, which in this case will be this one. And now same thing happens. Torii is being created on slot. I will get back a Torii URL, and then everything I've shown you, like locally working with GraphQL, with SQL, or with gRPC, I just have to switch the URL, and then I will be able to have exactly the same services. In a few minutes, everything is being setting up. So here the Torii is up, and if I go into SQL, I get back into my playground. And here in this case, I don't have anything. So if I just want to send a transaction, same thing. I can use the Sozo, and then I can just have to use the profiles, and I can do everything exactly the same. So as you have seen, it's very seamless the way you can change from local to playtest, even to production, because Katana is also meant to be used in production. And I think we reached the timer, but yeah, this is what I wanted to share with you guys. Sorry, go ahead.
I just want to read out the questions for the recording, just so that people who are watching it after the fact will understand. So someone has asked, are there any platform restrictions for Unity SDK and Torii client? Can a game run easy on iOS and Android?
That's a good one. For Unity SDK, currently, I think the support is not that bad. We have people working with already mobile app, but I will need to check exactly the state of it. And if you reach into the Dojo Discord, you will definitely have the more precise answers to that. But what's sure is like Unity SDK in WebGL works very fine. And when you build into native, it should be okay. And also with controller now being integrated directly into the SDK, even for wallet stuff, you will have direct access to the SDK capabilities. So yeah, you should be able to build something on iOS and Android.
And then they've also asked, do you have built-in, I'm assuming AA meaning account abstraction in Unity?
So I can be account abstraction or can be like the ranking of games. I don't know if this what the meaning exactly. Account abstraction on StarkNet is by default, so everything is account abstractions, and every account you use is actually a contract, a smart contract. But if AA refers to like a game like AAA games and something big, I think not yet. We have several games on mainnet actually on StarkNet currently, but I'm not sure if we have like yet something about AAA. But if it's account abstraction, yeah, you're right, Rebecca. Then yes,
Okay.
everything is account abstraction on StarkNet, and Dojo takes advantage of this, and controller also.
But we've got a bonus question as well there, if there are any AA games. Okay, very cool. Thank you, Glim, for giving this tutorial.
Thank you, Rebecca. See you guys. Have a good one.
Thank you.